What you're about to see is a motor analysis utilizing the infrared camera and the ultrasonic probe. We target the casing of the motor and identify 52 degrees centigrade temperature reading. We use the case temperature as a benchmark to compare the bearing temperature. An alarm will be signaled if we see a greater than a 10 degrees centigrade difference. Keep in mind that this is an indirect measurement and will be lower than the actual bearing temperature. As we move the crosshairs over the bearing, we see a 14 degrees centigrade increase in temperature. This indicates a strong possibility of a misaligned coupling, a bad bearing, or a lack of lubrication. The ultrasonic probe is used to determine whether this heat is generated by a mechanical issue within the bearing or a transfer of heat from the pump. The wave format will be analyzed through software to identify frequency peaks, noise content between those peaks, and amplitude on a time series display that will be compared to known examples of these type of problems. We now take a temperature reading of the back bearing. It's only a 5 degrees centigrade difference between it and the motor housing. It is, however, 15 degrees centigrade cooler than the front bearing. As we compare the temperature of the pump to the front bearing, we see the pump is relatively cool. This is not a source of heat transfer through the shaft to the motor. The recommended solution is to check the coupling alignment between the pump and the motor. We will also check for proper lubrication. If these two factors are not the issue, then the recommended solution will be to replace the front bearing. Utilizing infrared and ultrasonic technologies, we clearly isolate the problem area on this motor.